We are now going to discuss something called a reader-writer lock. So the idea of a reader-writer lock is it's a smarter kind of lock. If you think about the operations that you would put a lock on, then typically those operations would involve either reading the data or changing the data somehow. And what reader-writer lock does is it basically lets you read the data from several locations concurrently, or several threads rather, but it controls the writing process by sort of locking on the writing part and not letting several different threads write at the same time, which is a safe way of going about working with data. So let's take a look at how we can set this whole thing up. I'll get rid of the example that we had previously and we'll build something new. So the reader-writer lock is made using the reader-writer lock slim class. There is also an older reader-writer lock which isn't as good. The reader-writer lock slim, that's a more modern variety and it is better, and it is what you should be using. So we'll make this called padlock. So I'll make a new reader-writer lock slim. You'll notice that one of the arguments here is a lock recursion policy. And yes, reader-writer lock slim does in fact support lock recursion if you want to go in this direction. So let's suppose I have an integer variable called x with an initial value of 0, and I'm going to make lots of tasks which are going to change this variable. So once again, we'll have a list of tasks. Var task is a new list of task, like so, and then I'll make a loop. So I'll have 10 iterations of the loop, and inside those iterations I'll add a task, and this task, once again, I'll do task.factory.startNew. This task is going to do the following. It's going to basically output the fact that we entered some sort of read log. So we're going to read the variable first of all. So we want to write line. What I want to do is I want to simply write the value of x. That's simple enough, but I need to control access to this variable because at some point I might be writing to it. So the way this is done using the reader-writer lock slim is as follows. You basically say padlock dot enter read lock. So to read the variable, you enter the read lock, and then you can read it and output it to the console. So here I can say entered read lock, and x is equal to the value of x, like so. Okay, so then I'm just going to sleep for a moment, let's say 5 seconds, and then I need to exit the read lock. So I have to say explicitly padlock.exit read lock to sort of give up the lock, and then let's write line once again. So here I'm going to say exited read lock, and x is equal to the value of x, like so. So this is how you would control the reading. We're not doing any changes to x at the moment. So essentially at the moment we've just made these 10 tasks. I'm going to wait on them, so I'll have a try catch where I basically do a task.waitAll. I'll do tasks.toArray as we did before, and in the case of exceptions, let's say we get an aggregate exception, I'm just going to handle it by writing it to the command line. So I'll say AE, well, as soon as I give it a name, I'll call AE.handle and take the exception and simply console.writeLine the exception and return true, meaning we've handled it. And then what I'm going to do is I'm also going to have an input loop where I'll be actually trying to change the value of x. So while true, I'm basically going to read key, but once I'm done reading the key, I'm going to enter a write lock. So in this particular instance, not only do I want to just read the value of x, I want to write it as well. And in this case, I'll do padlock.enter write lock. And in fact, I'll notify about it. So I'll say write lock acquired. Then I might change the x value to some random number. Let me actually just make a random generator. Let's have it as static as well. So down here, I might change x to some new value. So int new value equals random.next 10 and then x equals new value. I'll also write line about it, so I'll say set x equals the value of x, obviously with interpolation, and then I will release. So I will exit the write lock, padlock.exit write lock, and then write line that the lock has been released. So write lock released. There we go. Okay, so I have the main thread doing the modifying and another thread doing just the reading. Let's see what happens when we actually go ahead and execute this. So as you can see, we've entered lots of read locks at the same time because all those 10 threads were spawned at the same time, and they both entered and then they both exited. And when I requested my write, that managed to appear only at the end because obviously I asked for it a lot later than some of the read locks. If I try doing it again and just try to outrun the creation of the read lock, sort of press it like this, I don't think I'm going to be able to, because they get created very quickly inside that for loop before I get a chance to do a read key, even though this is all obviously happening concurrently. So we've entered all those read locks and they have been processed, and subsequently when the time comes, I'll get my write lock. You'll see I get actually a lot of them where I get the write lock, I set the X, and I kind of release it as well. So what can we do with this reader-writer lock? Well, first of all, let's talk about recursion. Now remember, recursion is when you try to take the read lock twice. So let me just, if I just copy this and then copy this as well, then under the normal conditions, under the default constructor argument, I should not be able to do it. I should just get lots of exceptions. So for each of the threads, or each of the tasks, in fact, that we created, we got a lock recursion exception where the recursive read lock acquisition is not allowed in this mode. So what we can do is we can change the mode. We can basically go up here and provide an argument to the reader-writer lock slim constructor. There is a support recursion constructor. So now if I do this, then you'll notice the program is once again functioning. Okay, we enter our read locks, we perform the 5-second wait, and then we exit those read locks, and then I can sort of perform my writes as usual. So that basically shows you that if you needed, lock recursion support is there, although once again I don't recommend it because it's very easy to get lost and confused when using lock recursion, but sometimes it is necessary. So that's one thing. Another thing is something called an upgradable read lock. You see, what would happen if we try to take a write lock for some reason? Imagine we only wanted to read the variable, but we realized that we really need to change it. If you just do padlock.enter write lock here, what you're going to see is that you get tons of exceptions because you are not allowed to do this. Essentially, basically tells you this pattern is prone to deadlocks. Please ensure that read locks are released before taking write lock. If an upgrade is necessary, use an upgrade lock. So that's what we're going to do. We're going to use an upgrade lock in place. So if you want to use an upgrade lock, then instead of entering just an ordinary read lock, you have to do it differently. You have to say that you want an upgradable read lock. So essentially you say padlock.enter upgradable read lock like so, and of course when you exit you have to say you have to basically say exit upgradable read lock like so. And if you do want to write, like for example for every even thread, for every even task in our counter, let's suppose I do want to change the value of x, what I can do is I can promote, I can upgrade this lock to the write lock, and this is just done by using enter write lock like so. Then I can change the value of x, and then I can exit write lock here. So if I execute this, well, as you can see, I'm entering my read lock. I have x equals to 123. Then I take the 5-second pause, and only then can I do the next one, which once again comes with a 5-second pause, and so on and so forth. So this is how the whole process works if you're using upgradable locks. So this is all I wanted to say in respect to the reader-writer lock, or specifically the slim variety, which is somewhat better than the ordinary variety. It's essentially a more flexible lock where you can separate the reads from the writes and be very explicit about it.